the major change is happening. Instead of glibc, they are using Bionic C library. Have you heard of the Bionic C? No. Okay, so it's nothing exactly same as glibc only. The reason behind this Android, why Android did for Bionic C is that glibc is running under GPL. Again, it's a new term for you, I guess. No. Okay. So hope you know what exactly GPL means, sir. What? General Public License, sir. And what are the conditions are there under GPL? Simply, I don't want to explain everything. I simply am telling that if you are using GPL license, you are not allowed to distribute it commercially. Okay? So that's one of the reason. One of the reason, not telling you all reason, one of the reason they went with Bionic libc. Plus, they want to customize the glibc because glibc is very huge and very big. So our embedded hardware is very small. And it's have very less memory, power, CPU capacity and everything. So that's the reason they created new library called Bionic C, which has replaced glibc in Linux system. Okay. Then other libraries are coming in the picture, which is standard open source libraries. Then again one more changes happen. That is called Dalvik VM. In morning session, Saurabh was already explained about Dalvik VM. So here we are having X server and X server in Linux. It is taken over by Dalvik VM. Why Dalvik VM? Again, it is the same. They want to run the application by using very less memory, very less CPU usage, and more powerful. So that's the reason Dalvik VM come in the picture. I am very poor in Windows. And my laptop only having HDMI out. Okay. So Dalvik will come in the picture. Then on top of that, our application framework. Thus we can say application framework. We can say Android SDK. That's what we are discussing in the morning sessions. Sir. Android SDK will come in the picture. Then on top of that, Android application will come. So are you clear with this concept? In Linux, we are having same Linux kernel. glibc was there, but Android is replaced with the Bionic C and X server, X client concept. Instead of X server, X client concept, we are having Dalvik VM. And on top of that, we are having only one toolkit support, that is Android SDK. Again, native support is there, but I'm just telling Android SDK, and then application toolkits will come on top of that. Clear? Okay. I want to explain the exact boot process of Android operating system. How the Android operating system is going to boot. Okay. Suppose you have your own mobile phone, so you regularly restarting it, something went wrong or something like that. So what exactly is happening? What are the core parameters for booting an Android operating system? Okay. So it will start with the bootloader. What is bootloader? What is booting? That is not a technical answer. Starting means everyone knows. Booting means starting. How to define technically? What is booting? Yeah. So, anyone can explain very nicely what exactly booting means? RAM. Right? So bootloader is the initial parameter, some set of code or program which will initialize kernel to start with. That is bootloader. Okay? So there will be bootloader in Android. The bootloader will tell that okay, this is the kernel I found. Start this kernel. The kernel will start. Kernel will do all the memory installation, interrupt handling, memory management, everything will start running. Then there will be init script. That is the first script in all Linux-based system which has to be enabled to start with the OS. So after init script, we are telling that now init script is ready. Now you will start the Dalvik VM processor. Right? On top of Dalvik VM, our applications will start working, and our applications or whatever things will start working.
No, I think I'll just.
That's fine. Okay. So bootloader, kernel, init process, Dalvik VM, applications. This is the processor. Clear? I feel like people want to go for tea as early as possible rather than my session. Was quite boring. disconnected over. For SDK, Android development kit is interacting with the entire Android system. We have various layers: operating system layer, middleware libraries, application framework, and applications. This has been completely interacted from the developer toolkit. That's what we are discussing in the morning. Whatever the application development happening, it is happening through various layers. Like since this, it is hardware interaction. It has to happen through OS. Everything happens to OS, but sensitive are more connected to OS directly. And middleware libraries, suppose if you want to use any kind of engines, already available engines, suppose text-to-speech engine, TTS engine, that is part of middleware engine. Application framework, there are a lot of standard APIs are available for doing clock or various activities. That is application layer engine, then applications. This is a basic structure of functional Android SDK processor, exactly. Okay, now WPM mission, what exactly we mean WPM? What are the features of WPM? Okay, WPM is a virtual machine as exactly as in Java. Okay, in Android, each and every application is running on top of one WPM as a separate processor. So, suppose if you are running 10 or 15 applications in a mobile phone, simply we are having 10 or 15 the same WPM virtual machines are running on your mobile phone. So that much of beauty it is, and that much of powerful it is. Even we can run multiple VMs at a time. You can assume that how many VMs are running. You can assume just simply how much applications are running in your own mobile phone. Minimum 10, minimum not 10. I'm sure minimum 20, 25 minimum will be there. Right? Or normal mobile phone having to minimum 25. So this is that's the beauty of WPM. It can be work with any kind of low-level hardware without eating much CPU and memory. And it works beautifully without any kind of lagging in the performance or something like that. Okay? Okay. Now I am coming back to the your application development part. You know what exactly mean by APK files, right? Yeah. So that is the compiled binary form of an Android application. So how the process is happening? As usual, same. It is starting with Java source code file. Okay. Java compiler will convert into class file. Okay. There's a DEX compiler. It will create it a DEX file. Then there's a packaging mechanism AAPT. It will create the APK files. This is the process happening while you are compiling an application from your SDK. Okay. Okay. Now this is what I am talking about. So I told you about the exact boot process of Android. Bootloader, kernel, then init processor. After init processor, we are initializing service called as Zygote service. It is a kind of one kind of WPM only. On top of Zygote service, we are getting various kind of VMs. This is the top layer. Zygote service will started by init.rc or init process of kernel. Then it will initialize various VM various WPM. Inside that we have process 1, process 2, process 3. This can be applications or services. So WQM will start, then inside of WQM we have various processes. Various processes can be applications or service, whatever it is, and it is having shared memory to access the or manage the application on top of OS. Okay. Now I am coming back to the AOSP source code part. Have you ever seen the source code from Android website? No. Okay. Have you ever seen Linux source code? Kernel source code? Anyone? No. Any source code of any application? Okay. Thank God. Okay. How the standard source code will look like, sir? Any idea? I'm not talking about your application which you are making. In standard source code, or if you are looking for a source code of any application or what kind of structure it's having? In Linux, I am asking for. Any idea you have? Header files, then? Sorry? Macro declaration will come inside the program. I'm talking overall structure. README files, yeah, it's a good option. Make files. So what exactly make file means? You know what exactly make file means? Yeah, so makefile is kind of a, suppose if you want to compile a C program, or if you want to compile C program which is connecting each other, 10 C program which is connecting each other, okay, so how you compile that application, or C program? One option you have to compile manually, that is kind of huge, time consuming, and there is no dependency between the applications, kind of independent application, or you can connect each application to that and create a separate file. This is the file which I have to compile, and compile everything to that. That's called makefile. Okay, so Android IOSP also in the same structure. We are having the various branches for various activities. Okay, each branch having makefile, and there is a common makefile for making the entire Android operating system. Okay, so you can get the entire source code from the Android repository. Okay, you can download it, and you can do modifications. You can play with it. There are a lot of nice documentations available for doing various kind of modification in Android source code. Even you can change the boot logo, booting logo, or look and feel of the interface, or adding new devices support. Everything can be done inside the Android source code. Yeah. Okay. Yeah. Yeah, it is possible. That is not exactly in the IOSP. That is in bootloader. Yeah. Yeah. There is a bootloader introduced by XDA developers. You know XDA developers. You may have heard of the term. XDA developers is open source community is working on various Android, ROM and open source activities. Some of the members from XDA developer have released a bootloader. It's a fine-tuned bootloader U-boot, which can do multiple OS booting. It is only in the bootloader, nothing else. Like in our Node PC, you can install Windows and Linux too there. So it is only in the grep bootloader. So same thing can be done in the bootloader. Okay, so this is the basic parameters of the AOSP component. AOSP. What are the components are there? Bootloader source code will be there. Kernel will be there. Root file system. What exactly root file system means? See, whatever I told you about after init process, it is looking for file system. Okay, either it may be Zygote processor, WVM, whatever is looking for file system. That's called root file system. Inside that we'll have Bionic C library will be there. All the other dependency packages will be there. DALV will come in the picture. Hardware libraries will be there. Okay, these are the major basic components of AOSP plus GNU rule chain. If you want to do any kind of building, you need a tool chain or builder mechanism. That's called GNU tool chain, also a part of AOSP. Okay. Okay. Now, have you ever tried these commands? ADB fast boot. ADB you tried. Okay. So how to interact with the Android device? Android system, not device. Suppose you are having Android mobile phone, you can play with your Android mobile phone, but there is a ADB. We can establish a communication through the Android system, operating system, through ADB. Anyone tried this feature before? Tried. Anyone tried fast boot? Please don't try. Because ADB is kind of, okay, I have almost some more slides on that. Let me start ADB. Android debug bridge, ADB. We can do various kind of copying the files or pasting the files or running the application directly from there. Or we will get the shell of the device inside your PC. Okay? And we can install uninstall application from ADB. No one hasn't tried it? No? Tried? Okay. This is the standard feature while doing any kind of application development in Android. Okay, but fast boot is something different. See, in all the devices, the entire OS and applications are laying down in NAND memory. You know what is NAND memory, right? You know what is it's kind of storage area. Okay, it's in NAND memory. It's not easy to write and read and write directly. You can't do kind of partitioning, kind of what you are doing in Windows or Linux. Okay, so for that there are some, certain instructions that are there. We can rewrite NAND. We can repartition the NAND device. Okay, we can flash NAND. These all commands we can do. But if you are playing with your mobile phone, if you did something like that, your mobile phone will be dead for sure. Okay, so this can be done using fast boot. But the advantage is like that. So fast boot, if you want to do any kind of modification in your current running OS, current running Android device, if you want to update your kernel, you can do that, but it's on your risk. Okay, you can change you can flash the entire image. That is called ROM. Flash ROM. That also you can do. If you want to change the boot directory, if you change the repartition the NAND gate, you can do. If you want to change the logo, you can do. This can be controlled by the protocol called as fast boot. Routing is giving the permission to establish these commands. Yeah, fast boot command. Routing actually currently, because of the security reasons or this is normal device won't give access to the system. The system, not top layer. So if you did the routing, then we are getting access to the system. So before doing any kind of fast boot commands, you have to root your system. That's for sure. And if you're routing also, it's very risky to do this all these commands because you know the reason. Because you don't have right kernels and everything. So, but that is the reason I'm telling you next slide what exactly how to experiment with these commands. Yeah. So how to experiment with these commands? We have various options. That is the first concept called open hardware. Open software, you know what exactly open software means, right? Source code is available free for everyone. Okay, like there is a lot of open hardware is also available in the market, which is very cheap and you can play your game whatever you want to do inside that. The source code will be available for the OS, kernel, by the bootloader source code will be available, and also the hardware diagram and everything also will be, schematic also will be available. Okay. These are some of the examples for open hardware. You may heard some terms like this, Raspberry Pi, RPA may be very familiar to you, Arduino may be familiar to you, am I right? Beagleboard? No. Okay, so let me give you a brief idea about these things. These are the one of the development boards we can say. So for kind of doing any kind of experiments for booting a new Android OS or flashing the NAND, this is the right place to do all these experiments. Okay, this costing is very cheap, they are very cheap. Less than 3,000 rupees pricing of Raspberry Pi and also QB board is coming for 3,000 rupees, and you can do all these activities inside this board. Flashing the NAND, putting new image, building new kernel image, or doing the modifying the boot logo, adding new features extra, or adding new hardware. Everything can be played with this hardware. Okay, so I have one hardware with me, that's QB board. I have the QB board with me. I have some practical demo, but unfortunately we doesn't got the cable now. I don't know whether they got the cable or not, HDMI cable or not. If you got the cable, we'll be moving to other workshop room or something like. I can show the demo how to play with this QB board. Okay. Yeah, that's all. So I'll have some quick question Q&A session. Then afterwards we wind up. Any questions?